Okay, so with this one, it's going to be side, side, side. So we're not being given any angle measurements. So let's see. I'm just going to sketch this as best as I can. We have a long side of 23. We have 14, which, oh no, maybe that's a little less than halfway. Maybe I'll do something like that. Oh, that. Close enough. All right. A is 14, B is 23, C is 10. And we're missing, let's see, alpha would be over here, beta would be over here, and gamma over here. Now, if we tried to use law of sines here, we would get stuck because we don't have a pairing where we have all of the information. It's like no matter what, we're missing the angle measurement. So we can't use law of sines at all here. But with law of cosines, what we can do is solve for an angle measurement. So because in terms of law of cosines, we'd have all the information of the side lengths. So let's just choose an angle, doesn't matter which one. Let's say I want to solve for alpha first. So if I want to work with alpha, what I'm thinking in terms of my law of cosines and setting it up, the spot where alpha would come through is in that cosine piece at the very end. So what that means is that everything else should be in terms of b and c, like that should be b squared plus c squared, and then equals a squared. So in order to use cosine of alpha there, I'm going to need a squared on the other side of the equation, and then filling in the rest with the other side lengths that are not a. So filling in numbers there, a is 14, so I'm taking 14 squared equals b squared plus c squared minus 2 times b times c times cosine of alpha, which we do not know. And now I'm going to start simplifying. So let's see, 14 squared should be 196. Let's see, I'm just going to do the 23 squared plus 10 squared, so that should be 629. And then minus 2 times 23 times 10, which should be 460, and that 460 is multiplying with cosine of alpha. There's just simplifying some of the numerical calculations, and now what I'm going to work on doing is getting cosine of alpha all alone on one side of the equation. So we can do this a few different ways. I'll go ahead and subtract 629 from both sides of the equation. So that would give us a negative 433 equals negative 460 cosine of alpha. I'm going to divide both sides by negative 460. So that'll give me cosine of alpha is equal to 433 over 460. You could have the negative still in there, but negative divided by negative is a positive. So you could just have it that way too. And now I can solve for alpha by taking inverse cosine of that ratio there of 433 over 460. And then we just plug that into the calculator, and that is 19.73 degrees. So there's one angle measurement. Now we need to find a second angle measurement, because once we get a second one, then we can just use our 180 rule. And it's at this point that you have a choice. You can use law of cosines or law of sines. If you use law of cosines, we would just go through the same process. We would just change our formula a little bit. So what we would do for, like, if we wanted to solve for beta, it would be if we want beta where alpha was, then we'd have b squared equals a squared plus c squared minus 2ac times cosine of beta. And then you just plug in your numbers and go through and solve, which it works great. Or what we could do is law of sines, which I'll show here. It's typically the route I go, but again, it's either way. I know that sine of 19.73 degrees compared to 14 is equal to, and then I could put in sine of beta over 23. And then I would just be solving. So sine of beta is going to be equal to 23 times sine of 19.73 degrees over 14. And then to get beta, I would just need inverse sine of that number. 23 sine of 19.73 over 14. And that's going to be 33.68 degrees. And then we can use our 180 rule to get gamma of taking 180 minus 19.73 minus 33.68. So gamma is 126.59 degrees, and I drew that triangle terribly, but we're just going to go with it. This is 126.59 degrees. And that's completely fine, like on your written assignment, if you end up with a triangle like this where it's definitely not to scale, that's completely fine. I'm more worried about the numbers. I'm sure if I gave you the task of redrawing the triangle so it used the correct angle measurements, you could. We're kind of focusing on the numbers here, so don't worry if this happens where this is obviously not 126 or 127 degrees. That's completely fine. So with this one, using law of cosines to solve for an angle measurement, and then you can use law of cosines again, just switching around your variables, or you could switch over to law of sines to solve.